Welcome back to Speller Tutorial Services. Today we're going to talk about converting a rectangular equation into a polar equation, and we're going to express that polar equation in terms of r and theta. Let's just take a quick look as to how we can go from rectangular to polar. Let's take a look at this basic drawing here of a unit circle. Say this is a unit circle because the radius of this unit circle is 1. Actually, this is -1 down here and 1. I'm going to draw a radius r, write my radius r, creating an angle theta. Alright, and that's going to create a point here. Now the horizontal movement, I went x units, and my vertical movement, I went y units. So that says that this point here is actually xy. Now if I were to take the sine of the angle that we see there, we know that sine is the opposite over hypotenuse, which is y over r. Well, this can be expressed as y equals r sine theta, and that's just done by cross multiplication. And if we looked at cosine of theta, we see cosine is defined as the adjacent over hypotenuse, so that would be x over r, and again this can be expressed as x is equal to r cosine theta, and again that's done just by cross multiplying. So we see here that we can express, we have our y equation in polar format, and we have our x coordinate, not equation but our x coordinate in polar form. So using this information, we're going to substitute the values of x for r cosine theta and to substitute the values of y for r sine theta, and we're going to do that in this equation here. So instead of writing x, it's going to be r cosine theta minus 3 squared plus r sine theta squared equals 9. And again, that was just a simple substitution. What I'm going to do now is expand this out because we're going to have to use the FOIL method to get all the terms out of this quantity here. So we have r cosine theta minus 3 times r cosine theta minus 3 plus, well, this here is easy to evaluate, so we're going to go ahead and evaluate that. R squared, r to the second power is r squared, and sine theta to the second power is sine squared theta, and we continue with writing the rest. Now we're going to multiply this first term by that first term, which gives me r squared cosine squared theta. This first term by the -3 to give me -3r cosine theta. This -3 times that r cosine theta to give me another -3r cosine theta, and then -3 times -3 to give me a +9, and I rewrite the rest. R squared sine squared theta equals 9. Alright, now we're going to use some rules of algebra to break this down so it's easier to see what's going on. I'm going to subtract 9 from both sides as I combine some like terms. So these 9s go away. And the second thing I'm going to do is I see that I have a common factor of r squared for this term and that term. So I'm going to factor out an r squared. So I have r squared cosine squared theta plus sine squared theta. And I'm going to take this term here and I'm going to combine it with this term here because I see they're both the same. Coefficients are, I'm going to subtract the two coefficients. So I get -6r cosine theta, and all that is equal to 0. Well, knowing my trig identities, I know that cosine squared theta plus sine squared theta is the same thing as 1. So really this is r squared times 1, which is just r squared minus 6r cosine theta. And I really want this to be an r equals problem. So what I do is I add 6r cosine theta to both sides. Plus 6r cosine theta. So this here cancels, and I'm left with r squared is equal to 6r cosine theta. I divide both sides by r, so I'm left with r is equal to 6 cosine theta. So r6 cosine theta is the same thing as x minus 3 squared plus y squared equals 9. All right, that sums it up for this video from Speller Tutorial Services. Please friend us on Facebook or subscribe to our YouTube page. Thanks again for watching.